Okay, so in this video we are going to be attempting to prove that the derivative of arcsecant is equal to 1 over the absolute value of x times the square root of, let me see, what was it? Was it x squared minus 1 or 1 minus, I think it's x squared minus 1. We shall see. But that's the goal there, right? So, once again, arcsecant is a function whereby if you plug in a particular coordinate, it gives you a angle, and its inverse is a function whereby you plug in the angle and it gives you that coordinate. Okay, so thinking once again of a triangle with an angle of theta, secant is hypotenuse over adjacent. So this is my hypotenuse, x, and my adjacent is 1. So my hypotenuse is x and my adjacent is 1. And then using Pythagorean's theorem, we can figure out what the opposite side is. I'll put O for opposite there. So it's leg squared plus leg squared is equal to hypotenuse squared. O squared is plus 1 is equal to x squared minus the 1 on both sides. You get x squared minus 1 and take the square root, and you find out that the opposite side is the square root of x squared minus 1. And that will come in handy later on in our proof. Now we're ready to go ahead and begin. So the first thing that we're going to start off with in our proof is, as in the other cases, we do secant of arcsecant. And using the property of inverses, we conclude that this is x. Now, before I go any further, I forgot something. Got to remember back whenever we're doing our unit circles, right? You have the hypotenuse, but then you have the legs of your triangle. The legs can be positive or negative depending on where your triangle is located, but that hypotenuse always is positive. The hypotenuse always has to be positive. In other words, the hypotenuse is really not just x. The hypotenuse is actually going to be the absolute value of x. Okay, so that's the approach we're going to be taking, and that's where the whole absolute value thing comes from, because of the fact that the hypotenuse in this case has to be positive. Now in all the other problems that we did earlier, the hypotenuse was already a positive number like 1, or it was in a square root, which is also always positive, so we didn't need the absolute value. In this case, though, we have to be sure to put that absolute value symbol on there, and that's where it comes from in our final answer. So let's go ahead and continue. Once again, we take the derivative with respect to x on both sides. The right side is, as in the last two proofs, equal to 1. The right side, we do the derivative of the outside. Now the derivative of secant is a little complex. It's secant tangent, right? And since that's a little bit long, I'm going to need to stretch out some space here, because I'm going to need a little more space than that. And this inside does not change. Multiplied by the derivative with respect to x of that inside arcsecant, which is what I'm trying to find. So once again, we divide everything to the left of that to the other side. And we end up with the following. Okay. Well, let's scroll down a little bit here. Let's do some more math. We're almost there. We're going to go ahead and plug in theta, because we know that secant inverse x is theta. So let's go ahead and do that first. So the derivative of arcsecant is 1 over secant theta tangent theta. Okay, and at this point we go back up to our triangles and we look to see what these are. We need to figure out what secant is and what tangent is. Now secant is hypotenuse over adjacent. So that's the absolute value of x over 1. So I'm just going to replace secant then with the absolute value of x. And then tangent is opposite over adjacent. So that's square root of x minus 1 over 1. So it's the square root of x minus 1. I'm sorry, square root of x squared minus 1. Let's go ahead and do that. And that is the derivative of arcsecant. Well, hope you guys have enjoyed these proofs and appreciated them. And like I said, I mean, even though I didn't do all the trig and arctrig proofs, I left out 3 on all of them. I didn't do any cotangent, cosecant, or cosine on the trig or arc function ones. So, if you want to go ahead and use the ones I did give you as a model to try to figure the other ones out, I think that's commendable. It's something I would have done back in school, but you guys are busy. But those are the kinds of proofs I would expect you guys to turn in for your extra credit, and those are the proofs that you can reproduce on the test for extra credit. So we'll see you guys in class on Monday. Enjoy your Thanksgiving break.